Okay, so this is the bridging content for the CCNA test. It's stuff that was either newly added or was moved around, and I want to make sure that you guys had an opportunity to go over all of it. So you've all been enrolled in bridging, and basically what we're going over is security, which we did kind of go over security. So this is going to be a little bit of a refresher of security. And also wireless LANs, which we did not cover at all last class. And I wanted to make sure that you had all of that information. So yeah, there are some packet tracers, unfortunately. So there's still some more work for you to do, but this is it. Also in the regular class, I am sharing that window, aren't I? You can see my screen, right? Can you see my screen?
Yeah, we can see your screen.
Okay, thank you. So remember that horrific hands-on skills exam? That has been replaced by something that is much more reasonable. And it's just the standard hands-on skills. Oh, and I didn't attach it. Okay, let me attach it real quick. Oh, come on. I didn't put it there. Okay, it's on my other laptop. Anyway, it's much more reasonable. So please get as much as you possibly can done in all of your activities, please. Okay, let's move over to that. So yeah, as you can see, there is some more work to do. I'm going to go over both of the security lectures today, and then next class I'll go over both of the wireless LANs activities. I'm accepting work until the last day of class. So for all of you who are behind, don't panic. Do 1 or 2, assignments a day, and you'll be all caught up. Let me take a quick look at that. Okay. So I'm going to okay, so this says it's chapter 10 or module 10. It really isn't, but it's some of the basics of LAN security. As I said, we have gone over a lot of this previously, so some of it I'm going to gloss over. The videos are absolutely wonderful. I don't know who it is that they got to do the videos for these courses, but they are really good, and he's very engaging. I like his voice. I wish my voice sounded as exciting, but it doesn't. So we're going to talk about endpoint security, access control, layer 2 security threats, MAC address, and LAN attacks. Just some of the basics to keep you secure. Okay, why isn't it changing? Oh, okay. So endpoint security. Um, so there's, as far as network security goes and your endpoints, there's so many new network attacks daily. Even when you follow your best practices, we're never fully secure. So by implementing some high quality security end devices, we can minimize our security workload. Um, Denial of service, data breach, malware, all of those things are a constant threat. So some of our network security devices, we can use a VPN for secure tunneling, whether it's site to site or for remote workers. Um, we've got the next generation firewall, which is kind of like a unified threat management system, and that integrates many security appliances into one. And of course, we've got network access control for your AAA compliance. So for your authentication, your authorization, and your accounting. And of course, Cisco has their versions of this. So this is kind of the Cisco version of what we went over in the server class when it comes to security. So our endpoint protection. So our endpoints are going to be our users. So endpoint protection will most likely be managed by your host intrusion prevention systems. We can also, to make things secure, we can apply edge security appliances to better protect our endpoint devices. And that also allows us to manage our security centrally as opposed to one device at a time, which does make it way better. For Cisco, we've got our email security appliance, and the Cisco ESA is designed to monitor threats to SMTP. It's updated by Talos, and Talos is Cisco's security branch. And by the way, Beer with Talos is a great podcast from the Talos security team. They kind of sit around and discuss threats in a very relaxing manner. So, and it's cool to hear their perspective of threat management and some of the latest things that have been going on. So we've got a web security appliance, and it's a management tool for protecting our internet interactions. And it does that by filtering URLs and by malware scanning, web app filtering, and encryption of our internet traffic. And so that's pretty much what our web security appliance is doing. It's going to blacklist URLs that are bad. It's going to scan for malware and encrypt and decrypt your traffic. Access control. So not only do we need to think about, we're not really talking about access control lists here. We're talking about access control to our switches and our routers. And of course, don't use Telnet. We want to make sure that we have passwords for our authentication and that we're using SSH and that it's encrypted. So make sure that you're generating your crypto keys and creating good, strong passwords. So some of our AAA components, as you know, AAA is important in any computer networking or server environment. And it's a way that we can verify that people, the only people who are authorized to access our network can. So they get authenticated, they are authorized to access specific resources, and we have a detailed accounting of when they were there and what they did. So our AAA authentication, so when we're talking about logging on locally through the router, that would be our local AAA authentication. Or if we've got server-based AAA authentication, we're implementing a Radius or a TACAX Plus server to manage AAA for remote connections. And we'll be using the 802.1x protocols for verification. So authorization, of course, is most likely going to be managed through Active Directory. but you can manage some network resource access through your remote access permissions or your radius server. So accounting, log files. Oh my gosh, log files, right? We want a complete timestamp log with who accessed what and when. And that way we know who did what and when they did it. So as I said, 8021X is our standard, and it's a port-based access control and authentication protocol. And it restricts unauthorized workstations from connecting to the LAN through publicly accessible switch ports. The authentication server authenticates each workstation that's connected to a switch port before making available any resources offered by the switch or the LAN. So it's before, I mean, as soon as you get into the net, before you even get into the network, we're going to verify this. There's three parts. There's the client, which is the supplicant, the switch, which is the authenticator, and then an authentication server. And some of our layer 2 security threats. So one of the things to think about is, and what's really important is that if layer 2 is compromised, all of the higher layers are also affected. So you really want to protect your switches. Disable any unused ports, enable sticky ports, and add port security, because you really want to make sure that that everything is covered. So some of our switch attack categories, MAC address table, MAC address attacks. So these are some of the ways that switches can be compromised. Security, of course, is only as strong as the weakest link in the system. And layer 2 is considered to be that weak link. That's because LANs were traditionally under the administrative control of a single organization. And we inherently trusted all of the people and devices that were connected to our LAN. But today, with the bring your own devices and more sophisticated attacks, our LANs have really become more vulnerable to penetration. So we've got VLAN attacks and DHCP attacks, ARP attacks, address spoofing, spanning tree protocol attacks. So there's lots of things that we can do to mitigate some of those attacks. Make sure that you're always using SSH, you're always using secure copy protocol or secure FTP. Use SSL and TLS. Use out-of-band management network to manage devices. Of course, that basically means your native VLAN. Make sure that your native VLAN is for management. Use a dedicated management VLAN when nothing but management traffic resides. And of course, use your access control lists, because they're very important. So here we've got a MAC address table attack. And we've got forwarding decisions based on our layer 2 LAN switch, of course, which is based on MAC addresses and frames. And so here's an example of the MAC address table that's stored. So some of the things that can be done is MAC address table flooding, and those attacks take advantage of this limitation of the size of the MAC table by bombarding the switch with fake source MAC addresses until the switch MAC address table is completely full. And when it's completely full, we end up with a buffer overload. And then the switch treats the frame as an unknown unicast and begins flooding it, flooding all incoming traffic out of all ports on the same VLAN without even looking at the MAC table. This condition now allows a threat actor, of course, to capture all of the frames that are sent from one host to the other on a local LAN or local VLAN. And that's a big problem. So some of the tools like MacOff can flood a switch with up to 8,000 bogus frames a second, and that creates a MAC address table overflow attack in a matter of just a few seconds. Another reason why these why these attack tools are dangerous is because they not only affect the local switch, but they can also affect other connected layer 2 switches. So when the MAC address table of a switch is full, it starts flooding out of all ports including those that are connected to other layer 2 switches, which causes a cascading effect of a nightmare. There's a good video on VLAN and DHCP attacks. Actually, there's a lot of really good videos in here. VLAN hopping. So basically, your bad guy could spoof an 802, excuse me, 1Q signaling, DTP, dynamic trunking protocol. So back in the day when we were talking about a DTP for trunking, I had said that it's really important to make sure that we don't have automatic trunking enabled. So if it is enabled, the switch will establish a trunk line with a host, regardless of whether or not it's a valid host or not. So if you have a bad guy that has a switch, it can create a trunk with your VLAN by dynamically, just through auto negotiation. So and then the threat actor can send and receive traffic on any VLAN, basically hopping between all of the VLANs. So that can be a serious problem. Another problem is double tagging, and that's where you have two VLAN ID tags. And the first one is removed when it goes through the first switch, but the second one's still there. And this is a problem with your it's a problem with your native VLAN. So a threat actor in this situation could embed a hidden 802.1Q tag inside the frame that already has a tag. And that tag allows the frame to go to a VLAN that the original 802.1Q tag didn't specify, because it goes through the first switch, that VLAN tag gets taken off, and then it'll still have the VLAN tag for the native VLAN, at which point it can traverse all of the VLANs or any VLAN that is using that native VLAN port. So double tagging. So it's unidirectional, and it works only when an attacker is connected to a port in the same VLAN as the native VLAN of the trunk port. So that's why I say that you should make sure that your native VLAN is only used for trunk lines, and that your trunk lines are not auto-negotiated. So the idea is double tagging allows the attacker to send data or host servers on a VLAN that otherwise would be blocked by some type of access control configuration. Presumably the return traffic would also be permitted, and then that allows the attacker the ability to communicate with devices that are normally blocked. Because the whole point of a VLAN, right, is to segment your network and to make sure that you've got security. For our DHCP vulnerabilities, so here's a review of the DORA sequence of the DHCP message exchange between the client and server. So we've got our discover, offer, request, and acknowledgement. And there are some things with this that can be utilized as attacks. So DHCP starvation. You can use Gobbler to consume all of DHCP addresses in a pool, and then you've created a denial of service because nobody can get an IP address. And if you can't get an IP address, then you can't go anywhere or do anything, right? You've got DHCP spoofing as well, and that would be using a rogue DHCP server to deny access to a client by redirecting the traffic to maybe a wrong DNS server, or by creating a man-in-the-middle attack by an invalid gateway, or even by just denying the client access by providing an incorrect IP address. So there's lots of things there that can be a problem. There's a video on ARP attacks, STP, and CDP reconnaissance. Remember our Cisco Discovery Protocol. And I think a lot of the things that we're talking about in this security portion, I've kind of touched on at each of the stages in other lectures. When we were talking about VLANs, I talked about the importance of your VLAN, your native VLAN not being utilized for an actual VLAN. And I also talked about the importance of disabling dynamic trunking protocol and not allowing it to auto-negotiate. So this is a good refresher of that. We also have ARP attacks, and the ever common ARP attack has been around forever. Basically, we're going to have unsolicited ARP replies and spoofed MAC addresses, and that creates the perfect environment for a man-in-the-middle attack. And there's so many tools that can be used to accomplish this. Of course, you don't need to worry about this with IPv6 because there's no ARP, right? So if you're enabling dynamic ARP inspection, then we also can prevent some of this. So there's no real security mechanism at layer 2 that allows a switch to verify the source of MAC addresses, which is why it's so vulnerable to spoofing. IP and MAC address spoofing can be mitigated by implementing IP source guard, and that will allow manual configuration and of your MAC addresses and IP addresses. Not necessarily manual configuration, but it will prevent spoofing. We've got our spanning tree protocol attacks. So we love spanning tree protocol, right? Because it prevents spanning loops, right? It prevents loops. So one of the problems with spanning tree protocol, as I've said before, was an attacker, if an attacker has access to switch ports that are able to become trunk ports, then you can add a rogue switch into the network. Don't forget that Cisco switches have all of the ports in dynamic desirable mode by default. That means that if the ports are still in that mode, the attacker can connect the rogue switch and in his cubicle network wall jack, and then the switch will negotiate the trunk line with the switch in the company. So in that moment, he has the possibility to form another connection to the second switch that the company has, and then he's able to manipulate rogue switch spanning tree priority. So, so he can set his switch to have a higher priority, which is less than any other switch in the company, and then all the traffic will theoretically pass through that. Yeah, things to think about. And I think I remember when we were talking about spanning tree protocol and the BPDUs. I think I gave the analogy of, when you grab a switch out of a closet that hasn't been connected to your network before, you need to make sure that it's not going to overwrite the bridge protocol sequence that you have set up already. You've got the backup switch. Because remember, with STP, we're trying to make sure that we've got redundancy, and so it's going to block one of the connections. CDP, Cisco Discovery Protocol. It's absolutely wonderful for troubleshooting, but I've mentioned, I think, many times that the security risks associated with it. If you keep it enabled on your Cisco devices, you're asking for trouble. So please, oh please, make sure that you disable it globally. So to disable it globally, you're going to use the no CDP run. If you only want to do it on one port, you're going to use no CDP enable. So on that interface, and that's going to be in the interface that you're disabling it on. Another thing to think about, so we've got CDP, right, which is our Cisco proprietary, but we also have LLDP, which is our vendor neutral open protocol. And it's also vulnerable to reconnaissance attacks. So if you configure a no LLDP run to disable LLDP globally, and if you want to disable it on an interface, you're going to have to do a no LLDP transmit and a no LLDP receive, because you have to do both of those for that. So we talked about endpoints, denial of service attacks, data breaches, our AAA. We talked about the 802.1x standard, layer 2 compromises with MAC addresses, port security, DHCP, and all those other things. And this is actually a really good refresher of some of the things that we've discussed previously. So MAC address flooding, what is going to bombard the switch until the MAC address table is full, at which point it's just going to flood everything out of everything. We've got VLAN hopping, where we can go from one VLAN to the other without using a router. And that's a big problem. Double tagging is when you have two VLAN ID tags on a frame, and the first one gets removed when it's de-encapsulated, and then it still has the native VLAN ID frame tag so that it can traverse the network. So make sure that your native VLAN is only used for trunk lines. We've got DHCP attacks, basically gobbling up all of the addresses or spoofing IP addresses. I mean, gobbling up all the IP addresses or inserting a rogue DHCP server, which is one of the reasons why in Active Directory, right, your DHCP server has to be approved by your domain controller, right? So now you understand why that happens. And a number of different ARP attacks, which have been going on for years. STP attacks, so make sure that you're implementing a BPDU guard on your access ports. And CDP is wonderful for troubleshooting, as is LLDP, but you want to make sure that that's disabled after you're sure that everything's working properly, because what a great way of getting a complete mapping of your entire network. And you certainly don't want to provide that resource that easily through any bad guys. Of course, they can use their own tools to traverse the network and do reconnaissance, but why make it that easy for them, right? So that was the first part of LAN security, and we've got another one that I wanted to go through. Any questions or comments?
So, nothing really from me.
Okay.
Just comment from the last homework. When you posted the code, the little snippet of the Reddit link to the code, was he using Telenet or in that Reddit post? I know it's something kind of weird.
Yeah, I'm not quite sure which. Oh, yeah, I'm not quite sure. For I'm not quite sure which assignment you're talking about. So
It wasn't an assignment. It was some Reddit code you had posted for automation.
oh, right. It was no, it was I didn't post the code. I posted a link to
The
Reddit.
link, yeah, to the Reddit
Right.
post.
And because I wanted you guys to have a different opinion or different viewpoint of network automation from the perspective of sysadmins and network admins. Yeah, there's a deep, that's one of the things that I love about Reddit is there's so many experts. There are some real experts, and then there are some wannabe experts, but some of the real experts can really give you some great information regarding best practices and how to manage things and what the best code to use. I think the consensus was that Python is probably the best scripting language to manage things with. I mean, I think that's what I kind of gathered from a lot of that. So yeah. So let's see, switch security. I haven't shared that screen yet, have I? Okay, so switch security. Let's plow right through this. There really isn't that much here. So lots of things, to think about. So how do we protect our switches from all of those attacks that we just went over, right? And so this is going to show us how to implement port security and prevent all of those things. So previous chapter was sort of here's some of the problems that can occur, and this is how you can fix it. Securing unused ports. If there isn't a cable plugged into that port, you want to make sure that you shut down all unused switch ports. If you're using an old 3500, so in here they're showing you how to shut it down by the range. Oops. Let me go back. They're showing you how to shut it down by the range. And if you're using an old like 3500 switch with iOS 12.2, you can't use the range command, but you shouldn't be using anything that old anyway. So you can you can shut down the entire range of addresses from all of your ports, from port 1 to port 24 or 48 or however many ports are available on physical ports are available on that switch. And then you only open up the ports that you need to use, right? And that way you prevent that. So close all the doors first and then open up only what you need. MAC address table attacks. So your port security links the physical port switch port with the attached device's MAC address. So if we're using port security, then we can limit that, right? So we can't just plug in any old thing because it's going to map the MAC address with the port, the physical port. So, and here in this example, we've got switch port security command, and it was rejected. And that's because port security can only be configured manually on configured access ports or manually configured trunk ports. So by default, layer 2 ports, switch ports are set to be dynamic auto, which is trunking on. So in this example, the port's configured with switch port mode access interface configuration command. Trunk port security is kind of sort of a CCNP thing, but we should still know how to enable this properly. So if it's, so as you can see, if it was a trunking port, you can't do that. If it's not a trunking port, then you can. So you need to make sure that it's switch port mode access, which makes it an access port, not a trunking port. Enabling our port security. So here, notice how port security is enabled. The violation mode is shut down, and the maximum number of MAC addresses is 1, which means that it's going to shut down that port if it receives more than 1 MAC address attached to that physical port. So if a device is connected to the port, the switch will automatically add the device's MAC address as a secure MAC. In this instance, there's no device connected to the port, so it hasn't made that binding yet. And once we've enabled switch port security, other port security specifics can be configured. So you can have aging and how many MAC addresses will you allow that switch port to have? And what are you going to do if there's a violation? Are you going to close the port down completely? Are you just going to log it? or are you going to log it and shut it down? So we can limit how many MAC addresses the port allows. So here, by doing a switch port security maximum, we can set how many. The maximum is 8192, which is way too many MAC addresses. Why even bother enabling port security if you're going to allow it to learn that many MAC addresses for that one port? So the default port security value is 1, which is nice. That means that whatever you've got plugged into that port, it's going to check the MAC address, it's going to bind that MAC address to that port, and it's going to recognize if something with a different MAC address is plugged into that port. So 3 different ways that your switch can have MAC addresses linked to ports, either manually configured by doing the switch port security MAC address and then putting in the MAC address of that device. It can be dynamically learned. When switch port security is entered, then it's going to automatically see that. If the switch is rebooted, it's going to have to relearn the device's MAC address, right? Because remember that when you reboot a switch, it forgets all the things, right? So that's something that you need to remember. And if it's dynamically learned and sticky, then it's going to stick it to it. You can enable that by doing switch port security MAC address sticky. And of course, make sure that you copy run start. Save that configuration, and it will save that MAC address to our NVRAM, and you won't have to worry about it rebooting if it's sticky. So here we've got, I don't know how well you can see that screen, but basically we've got a maximum of 4 MAC addresses, and we're going to manually configure 1 secure MAC address and then configure the port to dynamically learn additional secure MAC addresses up to 4 maximum. And so we can use show port security interface to and show port security address to verify that we have the correct configuration. And port security aging, there's 2 different types. We've got absolute, so the secure addresses on the port are deleted after a specific aging time. Or inactivity, the secure addresses on the port are deleted if they're inactive after a specified time. So you're going to use aging to remove secure MAC addresses on a secure port without manually deleting the existing source secure MAC address. And here we've got the administrator configuring 10 minutes of inactivity. And don't forget, we can do show port security to confirm that it has accepted the changes that we want. Port security violation mode. So what happens if there's a violation? There's 3 different ways. It can either shut down, and that requires that the administrator has to intervene to bring that port back up. And in order to do that, the administrator has to do a shutdown and then a no shut. So you have to administratively shut it down physically, even though it's already shut down. You still have to manually go in there and do a shutdown and then a no shut on that port. And also restrict. So if it's had too many MAC addresses associated with the port, or if you have aging enabled, it will eventually fix itself, but it'll log it. And protect mode is the same as restrict, except it isn't logged, which don't use protect mode. You really want to use either restrict or shut down because we want log files of what's going on, right? So here's some of our violation modes. And if we do a show port security interface, we can see that it's enabled. We've got secure shutdown. So it'll shut down if it recognizes another violation. And aging is disabled, which is kind of interesting. So here are some, these are what your log file is going to look like, right? It's going to have a timestamp and then it's going to have what happened, right? It's going to show the error and the violations. So when a port's shut down and placed in the error disabled state, no traffic is sent or received on that port. The port protocol and link statuses are changed to down, and the port LED is turned off. So the physical port LED, well, if you're looking at the switch, it's going to be black. It's not going to be green and or amber or blinking or anything. So so we can see what is going to be in our log file by looking at this. So here, if we do a show interface, you know, if there's a security violation, the administrator should determine what caused it. If an unauthorized device is connected to a secure port, the security threat should be eliminated before re-enabling the port. Before you bring that port back up, figure out why that shut down. To re-enable a port, as I said before, first you have to do shut down, and then you have to do no shutdown if it's disabled, error disabled. To verify, excuse me, to verify your port security. So once you've configured your port security on a switch, you want to check each interface to verify that the port security is set correctly, right? And to check to make sure that static MAC addresses have been configured correctly. And to display the security setting for the switch, you can use the show port security command, and it will show you whether or not it's been enabled. So here we've got show port security interface command, and then we can see the specifics for each interface. So as we can see, we're on the physical port 18 on that switch. So that physical port 18. And so we can see that it's that port security is enabled on it. And here we're on the next physical port, which is port 19, and we can do a show run and see. And if we look at fast Ethernet 19, so we've got the show run command. We're piping it in to begin at interface fast Ethernet 19. We can see that there's a maximum of 10 MAC addresses that are enabled on there, and it's sticky. And if we want to see, if we want to display all the secure MAC addresses, we can do a show port security address. And there's a packet tracer, sorry, implementing port security. VLAN attacks. So some of the things we need to think about here is our dynamic trunking protocol, right? And spoofing that, which is awful. Spoofing DTP messages from the attacking host can cause the switch to enter trunking mode. And from there, the attacker can send traffic tagged with the target VLAN, and the switch is going to deliver whatever packets to the destination. So that's a big problem. Also, introducing a rogue switch and enabling trunking. So if you, an attacker can then access all the VLANs on the victim switch from the rogue switch. Another type of VLAN hopping attack is the double tagging or double encapsulated. So that's where you've got the two VLAN IDs on there. First one gets stripped off and the second one stays on, and that's specified for the native VLAN. So it takes advantage of the way the hardware on most switches operates, which is kind of unfortunate. So to prevent your VLAN hopping attempts, make sure that you disable auto trunking, right? By using the switch port mode access. So that basically all you're doing is taking that physical port and you're making sure that it's not a trunking port. It's an access port for a PC or whatever, a printer. Make sure that you disable unused ports and put them in an unused VLAN. There's something that we never talked about. You want to manually enable the trunk link on trunking ports by using switch port mode trunk and disable auto trunking. And that way there's no auto negotiation between any devices. It's a little bit more work, but it's so worth it. And make sure that you set your native VLAN to a VLAN other than VLAN 1 using the trunk switch port trunk native VLAN. Don't use 99 because that's what we've always used before. So use something else. I guess you could use 99, but everybody expects that. For our DHCP attacks, so some of the ways that we can prevent that. So we've got DHCP spoofing attacks, and they can be mitigated by using DHCP snooping and port security on our ports. So if we're doing that, then we've covered ourselves pretty darn well. DHCP snooping is going to filter messages on untrusted ports. The DHCP table is built that includes the source MAC addresses of a device on an untrusted port, and then the IP address is signed by the DHCP server to that device. So the MAC address and the IP address are then bound together, and so the table is called the DHCP snooping binding table, and that way they're only trusted devices, trusted sources. So to do that, you're going to enable, we're going to enable this globally on trusted ports. And so we're going to enable DHCP snooping by doing IP DHCP snooping in global config. And then we're going to, on trusted ports, use IP DHCP snooping trust and a limit rate of packets per second on untrusted interfaces. So IP DHCP snooping is a really good tool. So here we can see that DHCP snooping is first enabled on switch 1. The upstream interface on the DHCP server is explicitly trusted. So F05 to F024 are untrusted and are therefore rate limited to only 6 packets per second. And then DHCP snooping is enabled on VLANs 5, 10, 50, 51, and 52. So just by taking care of a couple and doing a couple of additional steps, we can secure our system way better and secure our network way better. So here, if we're looking at show IP DHCP snooping to verify that it's okay. So we can do that in privileged exec command, to verify our snooping settings. We can do show IP DHCP snooping binding command to view the clients that have received DHCP information. And DHCP snooping is also required by dynamic ARP inspection. So if you enable dynamic ARP inspection, we're going to have DHCP snooping as well. So do all of the things that protect your network, right? So mitigating our ARP attacks, let's talk about our dynamic ARP inspection. So in a typical ARP attack, basically a threat actor can send unsolicited ARP requests or replies to other hosts on the network with the MAC address of the threat actor and the IP address of the default gateway. And to prevent ARP spoofing and the resulting ARP poisoning, the switch has to ensure that only valid ARP requests and replies are relayed. And we can do that through dynamic ARP inspection. So here we've got some guidelines. So to mitigate the chances of ARP spoofing and ARP poisoning, you want to enable DHCP snooping globally. You want to enable DHCP snooping on selected VLANs. You want to enable dynamic ARP inspection on selected VLANs and configure trusted interfaces for DHCP snooping and ARP inspection. It's really best practices to configure all access switch ports as untrusted and to configure all uplink ports that are connected to other switches as trusted. And that way we can mitigate some of the vulnerabilities that can occur with MAC attacks. So in the previous topology, switch 1 was connecting 2 users on VLAN 10. So here we've got an example of enabling DHCP snooping, enabling it on VLAN 10, enabling ARP inspection on VLAN 10, going into interface F024, and enabling snooping trust and inspection trust. So we can also configure this to check for both destination and source MAC addresses. So we're getting more granular by checking both of those. So that's very nice. Let's have our equipment do the security work, you know, to protect itself. So here we've got inspection validate. So we can enter multiple IP ARP inspection validate commands. When you do that, it overwrites the previous command. So if you're going to include more than one validation method, you have to enter them on the same command line. So here you can see if I do ARP inspection validate, it's overwriting things until I put the ARP inspection, IP ARP inspection validate, and then the source MAC and the destination MAC IP. So we're going to do that all in one line. We're not going to do that in 3 separate commands, because if you do it in 3 separate commands, it's going to overwrite the previous command. So as you can see, when you do show run, it's only showing the validate IP, which was the last command that was entered. So make sure that you do all of those on one line of code, and then it won't overwrite it. And spanning tree protocol, portfast and BPDU guard. So portfast and BPDU guard should only be configured on user interfaces that are attached to end devices. And remember that attackers can manipulate STP, changing the root bridge and the topology of the network just by plugging in a switch, auto-negotiating a trunk, and taking over by having a lower ID. So we can enable portfast on an interface. So portfast bypasses the STP listening and learning states, and to minimize the time that access ports have to wait for STP to converge. So only enable portfast on access ports. Portfast on inner switch links can create a spanning tree loop, and we don't want that. And to verify whether or not portfast is enabled globally, you can either use the show running config and then pipe that into begin span command, or you can do a show run spanning tree summary command. To verify if portfast is enabled on an interface, you can use show running config interface and whichever the type and the number. We can also use that for verification. So show spanning tree interface, the type and the number detail, and get more information. So BPDU guard. So we can enable this either on an interface using the spanning tree BPDU guard enable, or we can do it globally using spanning tree portfast BPDU guard default in global config command. And that will enable BPDU guard on all access ports, which is probably the best way of doing that, since we want to enable this on all access ports. Why not just do it globally? So there's a packet tracer for that, securing unused ports. You can do it by range, which makes it way easier. Manage your switch ports, all of your physical interfaces on your switches. They should be set for access mode, not trunking. By default, trunking is on, so we want to turn that off. We want to make sure that, as I said, dynamic auto, which means trunking on, is set by default. So disable that. Set them all as access ports in a range. Enabling port security prevents MAC address attacks. And you can mitigate VLAN hopping by disabling dynamic trunking protocol negotiations. Make sure that it's not auto-negotiate, that it is manual configuration. Disable unused ports, manually setting trunking where required, and that VLAN, your native VLAN should not be VLAN 1 ever, ever, ever. DHCP starvation can happen by somebody using a gobbler, and it creates a denial of service because if you don't have an IP address, then you're stuck. Also, snooping is going to, so we're going to have to worry about snooping if we've got a rogue DHCP server. We want to make sure that we enable dynamic ARP inspection, which requires DHCP snooping, and it also prevents your ARP attacks. So if you just follow some of these really simple security procedures, you can really save yourself a lot of headache and a lot of work. Okay, so that's all I've got. Please make sure that you log into Netacad and you go into the bridging class. It's a separate class, and take care of some of the assignments that are there. They're not all that heavy. If you want to start working on the wireless LAN, packet tracers as well, you're welcome to do that. Or if not, you can certainly wait. I'm accepting, so it looks like there's really only one packet tracer for security, and a couple of quizzes, syntax checkers, just that you know how to implement the tools, and check your understanding activities. There's a few of those. And I will enable the lecture. Publish that. Oh.